Okay, so we want the derivative of x, because we're just going to switch the x and y in our arc length formula. So derivative of x with respect to y, 3/2 comes down, multiplies, and then the power gets reduced by 1, so now this is a square root, because 3/2 minus 1 makes 1/2. Then we need the chain rule, so we're going to multiply by 2y on the inside. Okay, so let's try plugging that into the arc length formula. We're square rooting y squared plus 1. Then this is times 2y. This is all being squared. So this is 1 plus square root squared. Gets rid of it. Then 2y squared, that's going to be 4y squared. So we can distribute. So it's 1 plus 4y to the 4th plus 4y squared. That can be factored inside there. So that's factored to be, if you rewrite this in descending powers, it's 2y plus 2, I think, times 2y plus, no, sorry, 2y, it's got to be 2y plus 1, 2y plus 1. The long way of doing it would be you line it up in descending powers, multiply the first and the last number, and then your goal is to find two numbers that multiply to be 4, but add up to be 4, the middle term. And then you would factor by grouping. But you should get this, because look, if you multiply these two parentheses, this gives you 4y squared plus 2y. Oh, this has to be squared, sorry. Okay, now it's right. Because this is going to give you 4y to the 4th plus 2y squared plus 1, just like we're supposed to. So in other words, it's multiplying to itself, right? So all that tricky algebra helped us simplify this to a nice, easy integral. And we can drop the confusion about negatives because we're integrating on positive numbers. So this is 2 over 3y to the 3rd from 1 to 6. And this is the antiderivative. This term is just y from 1 to 6. So that's 6 to the 3rd. So that's 432 over 3. Wait, that's divisible by 3 though. So that's 144 when I plug in 6. And then subtracted by 2/3 when I plug in 1. And then this is 6 minus 1. So that's 150. So it's 149 minus 2/3. Or if the software wants it just as one fraction, I can get common denominators. 149 times 3. Subtract by 3. So that's 445 over 3.